All right. So, sorry. As you can see from the diagram here, you can see that the codes are being shipped into a repository. So, you some of the repositories that are being used for versioning could be, you could use Git, you could use Jira, and you could also use Azure DevOps or VSTS as it was formerly called. Now, with the one of the advantages of DevOps as well is maintainability. You have effortless process of recovery in the event of a new release crashing or disabling the current system. Now, with the with the availability of versioning, and also with the availability of DevOps, you're able to store your codes in a central repository, which can easily be recovered should should you have crashes or should you have failures when the product is in use, or during maintenance here. Now, due to the collaboration and effective working of both the development team and the operation team, now you are able to ship your product to the market on time. You are able to develop your product faster. You are able to develop and also you're able to release your products in in silos. In different. For instance, you can have 1, 2, 3, 4 releases. So as a result of the collaboration between the two teams, the operational team and the development team, you're able to get things faster to your supplier, to your consumers, or to your customers here. And then another good quality of another reason why DevOps is used is because of greater quality. Now, DevOps helps the team to provide improved quality of application developments as it incorporates infrastructural issues. You have reduced risk. Now, it incorporates security aspects in the software delivery lifecycle. This helps in reduction of defects across the lifecycle. So, as a developer is writing these codes, a tester is doing a test on them. You are able to you're able to declare or detect bugs on time. And as you are able to detect bugs, this is being able you're able to overcome this challenge. You're able to rectify the bugs. You're able to so that as you're doing this here, because you're working in sync, and things are being done simultaneously, and as a result of that, you have a good chance. There's a good chance of producing goods and products that have been properly tested and have reduced risk. So you are reducing the chance of your products crashing or going into or being deployed, and then you're having issues here. And then there's also resiliency. The operational state of the software system is more stable, secure, and changes are auditable. So through your configuration management and through your versioning system, you have good and stable products which can be easily which are easily maintainable and all that. Yeah. And also, as a result of the collaboration between the development and the operational team, you have a good chance of saving money as well. And then the last one, but not the least one, sorry, is the breaks larger code bases based into small pieces. DevOps is based on agile programming method. Therefore, it allows breaking larger code bases into smaller and manageable chunks. As I said earlier, it gives you the opportunity to have your products released in phases here. So rather than you just working from A to Z and then releasing your products, you can then phase the release of your products in little or manageable chunks, and that's it. Now, so on this screen here, we have a DevOps glossary. The following are the terms and tools within the overall principle described above that successful DevOps engineers need to know. Now, the one important aspect of DevOps is the cloud, and the cloud is where all these the pipeline and all your virtual machines and all the virtual infrastructure is kept here. So we have the infrastructure as a service. If you work in IT, you would have heard of the public cloud. Uh, if you've heard of the public cloud, then you've heard of the leading cloud vendors such as Amazon Web Services, AWS, Microsoft Azure, Google Cloud Platform. These are the infrastructure as a service vendors that provide computing resources to customers via a public connection over the internet in a virtualized environment. These resources include storage, bandwidth, virtual servers, load balancers, network connections, and IP addresses. Basically, everything that you need is in the cloud. All you need to do is just to have access details to those to the infrastructure, and then you can then begin to use it as a result of that here. So as I said earlier, we have the AWS, Amazon Web Services, the Google Cloud Platform, Azure, IBM, and DigitalOcean. And there are also some other infrastructures as well. We have the software as a service, and we have the platform as a service. The software as a service is an example of that is your Facebook, where you have your facilities to do emails, facilities to do voice over the internet, telephone conferences, and all that. So another important aspect of DevOps is Agile and waterfall. So waterfall is a methodology that separates the various phases of software development and delivery and executes each phases in a linear manner. So as you can see from this diagram, you have we have all the phases of software development in a straight line. You have to complete one process before you go on to the other. You do your analysis, planning, your design, one after the other. You have to complete one after the other. As a result, code may not be developed until a project is well on its way, and the important phases of testing and quality assurance may be shortened or omitted altogether if there are delays in a previous phase. Now, if problems are brought to light in testing or quality assurance, the software has to be recorded or go even further back in the development process. So for each of these stages would have to be completed, and as a result, there might be delays, there might be issues, and then the other stages would not even come into place because you have to complete each of the phases before you move on to the next one. Now, but with Agile is a methodology that looks at business and software development projects in a non-linear way. That is consequently more efficient. Now, testing is implemented early on and often so that developers can fix problems and make adjustments while they build, providing better control and over their projects and reducing a lot of risk associated with the waterfall methodology. Now you can see, sorry, this is not really clear. Now you can see that with the Agile methodology, you have your planning, and then during your planning, before your deployment, you have your design, build, and test. So this goes in it goes in a circle, and then it goes into deployment. And then, so as a result of Agile, you can break your activities into little chunks called iteration or sprints, and then you release your product with the goal to release a product at the end of that particular cycle or iteration here. Now, as I said earlier, we have continuous integration. This is where developers, testers integrate code into a shared repository multiple times a day, and each isolated change to the code is tested immediately in order to detect and prevent integration problems. So this is one of the advantages of DevOps. Failures or bugs or defects are easily detected and then resolved. Now, examples of tools that you can use for continuous integration includes Jenkins, TeamCity, Travis CI, and Circle CI. Now, with another aspect of integration and delivery is continuous delivery. It's an extension of continuous integration, and the next step which is the next step in incremental software delivery. It's also This ensures that every version of the code that is tested in the continuous integration repository can be released at any moment. Now, Jenkins is a form of pipeline that you can use for continuous delivery as well. You can also use TeamCity, Electric Cloud, Amazon Web Services, and Code Deploy. Now, one other aspect of to consider as well is also continuous deployment is an extension of continuous integration, aiming to have a new code deployed in production to be used by a user. So as you are integrating your code, yeah, you can also release them once you are sure that everything it's been tested, it's been deployed on so many other services. It met all the requirements or criteria as specified by the business case. And then you can also deploy from there. You can also deploy, and it can goes into production where users or can make use of the product here. Now, in a nutshell, we have configuration management, which is a process of maintaining up-to-date, detailed record of hardware and software, including versioning requirements, network addresses, and design and operational information. So basically, as you are doing your continuous integration and deployment, as you are building your codes, as you are doing all the activities within DevOps, you need to have an up-to-date records of these hardware changes, these software changes, and all your versioning requirements as well, so that you can. An example of the tools that can be used for that include Chef, Puppet, Ansible, and all this can be used to aid the process here. Now, another thing that you need to know about DevOps is containers. I'm sure, I don't know if any one of you have heard of Docker. Docker is a lightweight virtualization component which helps you to hold your microservices, and then which runs in isolation, and basically they are hosted in the cloud, and they help you to run all your services or isolated services separately, all working together to give you the application that you are building here. Now, they run on their own processes, file system, and network stack, and they are all virtualized using the root operating system or running on the hardware. Now, Docker is a well-known example of container. Kubernetes, Elastic Box, and all that are also examples of those as well. Now, one other important aspect of DevOps is versioning. Now, versioning includes practices and tools that helps organization maintain and control changes within their source code. So basically, as a developer is building the codes for the application, and the tester is also taking these codes, writing his own automation scripts, and then checking to ensure that the codes that the developer have written are all working correctly. Once the test have passed and everything is been okayed, you push this up into a versioning control system, which then where you can then which maintains your code and all the changes that you may want to make to it in future. Yeah. Now, examples of versioning control includes GitHub, Bitbucket, and Artifactory as well. So Azure DevOps is also an example of a version control system as well. Now, for defect maintenance and bug tracking, these are systems that you use to track and maintain bugs and defects here. It helps you to manage your tasks very well, and it also helps you to ensure that configuration management also of your activity, and it also helps you to measure time, efforts, and other things and as well. Now, examples of bug tracking tools include Jira, VSTS, Azure DevOps, and bug track and all that. So one other key aspect of DevOps is automation testing. Now, test automation facilitates uh, work by supporting multiple tests that can run continuously. It helps tests it enhances test coverage while supporting efficient release cycle. So basically, what you would have well, basically test automation just makes life easy. In a nutshell, uh, ta- lots of codes, lots of things can be done with test automation rather than manual testing. And for example, test automation tools helps manage, execute, and measure functional tests and load tests. So examples of these tools could include Selenium, Cucumber, JUnit, TestNG, JMeter, and SpecFlow. One other thing that I need to mention about test automation also is about you can also carry out non-functional testing such as performance testing, um, looking at the performance of the application you are building, looking at the stress, carrying out stress tests, scalability tests, and also security tests, and also accessibility tests for people that have either impairments, they are blind, they are deaf. These are the kind of things that you can also use test automation for. Unit testing which is usually done by the developers, is a process that allows testers to examine small parts of an application, such as a specific code or module. These are also part of DevOps, and they are usually done by developers. Now, monitoring is a primary element of IT performance management and is one of the most important aspects when operating online services. Monitoring tools are essential and provide crucial information that helps to ensure services robustness in terms of availability and security. So basically, this, in a nutshell, this is just all about DevOps. Uh, and we will now quickly move on to Azure DevOps here, which was formerly VSTS. Bear with me. Now, what we will be looking at tonight is how to create a test plan, how to create test cases within test plan, how to add manual test scripts to the plan, how to execute the test cases, and how to create bugs fulfilled test cases, and also viewing the test case reports. This is showing on my screen now is Azure DevOps, and basically this is the landing page where you have your project here. Now you can create a project by simply clicking on this button and then giving the project's name and the description of what you want to call your project. Yeah. Now I've already created a project which I've used previously, and I'll be using that tonight as well. Now, if I go into my project, which I called Selenium SpecFlow Training, to the left side I have my dashboard, and on the main screen I have my my boards and widgets and all that. Yeah, these are customizable. You can move this as you want and all that. Now, when you click on your dashboard, it gives you an overview of what your project has. From there, you can manage your work. You can collaborate on code. As I said earlier, collaboration Git is a form of versioning. You can add code to your repository. You can continuously integrate, and you can also visualize your progress. And now from there you can open Visual Studio, which is your IDE, or where you build your automation scripts here. Now to do it to create a test plan, you come to your board here, and then you see basically this is my board here. with different backlog items. So basically, backlog items are maybe you can call them epics or stories which you intend to do within your uh, designing or software development process here. Now, uh, for instance, I could create a backlog item to say, let me call it create registration page. Now, so this is a backlog item. Now, within this backlog item, I could then say, I can add a test case to say registration here. Now, if I click on that registration, yeah, I could add test. So basically, what I'm doing now is creating a test case. So I've created a set. I've created the backlog item. Then I've created a plan, yeah, and then within the plan, I'm adding a test case to it, yeah. Now, so as I said to you, agile involves you creating having iterations of work activities to create your application there. So now within my test case, just as did you showed you last week on the Excel sheet, it could mean you have to put your steps to create the test case. So it could mean navigate or go to. If I navigate to, let's say, giftrate.com, yeah. Now when I click on registration link, I should be on the registration page. Yeah, and then here, whatever you expect to come up on the page is what you put here. So you should expect that the registration page should be displayed. Or you can just say registration page is displayed here. That is the expected result. Right. And basically you save and close. Now, depending on the priority that you want to give to your depending on estimation of estimation of how long this activity will take to test or design this page, you give it a priority and all that. So and then you can then close it. So within this backlog item, I have created a test case, and my test case is called registration here. Now, one thing I can do about this test case is I can run this test case. If I click run, yeah, it basically opens up a window. Now, running this test case, it means when I navigate to giftrate.com on my browser, for instance, if I open this page here, I'm just using this as a demonstration. I'm not actually following what is on this page here. So let's say, for instance, you navigate to that website. Yeah. Once the website opens, you tick this box, you tick this circle to say test pass. When I click on registration, if the registration page is open as expected, you tick on it, and oh, sorry, I've duplicated this here. So when I click, sorry, it should be click on registration page. Yeah, when you click on if you can see the link, you tick this, and then when the page is displayed, you tick this. Yeah, and then you save. So for instance, if you went to that page and you could not find this registration page, you tick the X box. You tick this one. That means that particular step has failed. And then you could put your comment says registration page not showing or not coming up, and then you create a bug here, and then you click save to create a bug. Just bear with me. I don't know why this is. Yep, that's fine. So basically, when you click that to create your bug, let's say failed. We can call this the title of this bug a failed registration page. So okay, let's say registration page failed to open. That's the title of the bug. And it's a new defect that is being reported. You can tag it to maybe your team. If your team is a white team, you can tag it. You can also tag it to maybe you're writing it in C# or whatever. You can tag it there, and you can tag it to maybe it is release one of your projects, release one and all that. So you can tag it. You can even tag it to your name if you want or anything, depending on what the tagging on the naming convention of the place where you are working. All right. So from this now, you can see that I have just created a bug, and then it has from the bug that has been created, I can see that it's failed on this step where the registration page should be displayed. So the expected result was registration page should be displayed, but my comment is the page is not showing. I cannot find the page. So basically, this is a bug that you've just created, and then you can save this bug here by clicking close and save. Now, before I do that, yeah, one thing I can quickly say again is you can link this to an existing item. So let's say I want to link this to another story or another work item. I can click link. Yeah. So it's a successor of so all right. So before you go into an application, you have to register. Yeah. Now, so a successor is before. No, sorry, a successor is after. So I can say, let's say for instance, I can change this to a predecessor. So I can say this is a predecessor of a login item because I have to register first before I log in. So I can say it is a predecessor of login item. So I'm linking this bug to a subsequent item. Yeah. So you can either click on the log ID or you just click on the item. So oh sorry, I've duplicated it twice. So I'm linking this bug to login page, and then I can put could not, just the comment, could not register due to the registration page not loading or whatever. You can put anything there, just a brief description of what the issue is, and then you click OK, and then you save. Field cannot be empty. Just build with what field? Just what field is this? Oh, sorry. Field registration page. Right, that's it. So bear with me. Yeah, that's it. So I have created that bug, and then I can close it down. So you see on your backlog board that the bug has been created for this test plan. Yeah. Now, before quickly, I've shown you two things in one go. I've shown you how to create a test case, and I've also tried to run the test case and then raise the bug for that failure. So another thing I can do quickly show you is here. If I click on test plans, I have all my test plans and all the associated test cases which I have run against them. So for instance, this is the one I just ran now, the registration page, the registration test case. So for instance, if I was to come here, if the bug has been rectified and the defect has been fixed, I could come here and then rerun this again. So if I wanted to rerun the test, all I needed to do was come to the test plan, uh, look at click the test plan, look at the test plans that I've created, look at the associated test cases within them by just clicking. So when you click on any of these test plans, you see the associated test cases that are linked to them. So I could just click on this one uh, and then rerun it. So by rerunning it, all I needed to do was to click on run and run test again here. So the page, this same test cases comes up, and then as you go through the pages, you can then click on them as if they display the expected results, and then close. So by the time I've closed, by the time you do that, then it will now change from failure to a pass. And then one other thing that you can do is you can also run a test report by clicking on runs. You come here, you click on run, and then it will show you all the tests that you probably ran by going through the steps I've shown you. And then what you can do, another thing that you can also do is to come back here, right click on each of those test cases which you have actually gone through or ran. You right click on them to view the test case report here. So when you right click and view the test case report, it will tell you, it's give you the details of the test passed, the duration, and the steps that are passed. And if you have any attachments or anything, you could just add attachments to it by clicking on this one, browse and add attachment, and okay, and do all that here. One other thing to show you is this is your board, uh, this is the backlog items. So as I said to you, Agile involves small and short iterations here. Now in your backlog is the list of things that you intend to do. You now pick them based on the priority of how you want to based on priority. So most times the product owner would would pick items from the backlog and put it within a sprint and say, oh, based on priority, based on what the business wants, this is what we need to develop first. Now, so I've just created all these backlogs as a dummy backlog, and then you can then the product owner you can then put them within sprints, and then take them one after the other. So for sprint one, these are the items. There are 8 items put within sprint one, which can go into development, and as you move on, as you move on from one as you progress with your with your development and testing activities, you can then move these items from one part of your board to the other, and when you are finished with them, you can leave them, you can put them in done and all that. So basically, this is just a brief overview of how to create a test case, a test plan, run your test manually using Azure DevOps, and also view the test results and all that. We have 10 more minutes before we finish this. Does anybody have any question, please? Okay, all right. So please, can you make your PowerPoint slide a bit larger? All right. It seems too fast. Could this be my network? I can't see anything. All right. I'm going to show you my PowerPoint again. Sorry about that. I wasn't looking at your. So this is my PowerPoint, and I'm sure the video will be available for you to go through again very soon. So this is the PowerPoint. I think you are going too fast. Sorry about that. We needed to cover a lot. Sorry about that. The PowerPoint will be available for you to go through, and you can then take time to read it and do more research on that. Yeah.
I have a question.
Yeah. Go on, please.
Yeah, sorry. How do I download the DevOps?
All right. So it's just all you need to do is to go to the internet. Yeah.
Okay.
And then what you need to do is to go to Microsoft.com. So Azure DevOps. So Google Azure DevOps, and you go to yeah. So Microsoft.com. Yeah. Can you see my screen?
Yes.
And then all you need to do is to register. So because I've signed in already, that's why you can see my name here. So all you need to do is to register, put in your name, and then just go through the registration details, and then it will take you to the landing page, which is this one. But by the time you open it and create a profile for yourself, you wouldn't have any projects coming up here. And one thing I need to show you quickly is you can also add people to be part of your organization. You can add users. So if you have friends that you want to play around with things, you can add users. You can add a user. You can give them access levels and all that, stakeholder, blah blah blah, and you can also but by the time you add them, you can assign tasks to them. You can assign test cases to them to run. You can move things around and all that. So it is a web-based application that you can, and it's free to use. Yeah.
Okay. Thank you.
Yeah. No worries. Yep. Does anyone else have any other question, please? Yeah. Thanks, Deji. Yeah. Azure is it's free. Yeah. All right. So did you saying that you would have the opportunity to lay your hands on Azure during the 3-month internship?
Yeah.
So
Hello.
yeah. Hi.
Hi, please. I have a question, or I'd like to make a request. How do we get the PowerPoint slides?
Well, that will be available with Deji. I'm sure it's going to I don't know. Maybe you'll probably post it on the website at the end of the meeting. Yeah. Or maybe whenever the video is available as well.
And the name, I don't know, maybe I missed it. The name DevOps, what does it actually mean?
Development and operations. So it's an acronym, yeah, coined from development. So if you look at my PowerPoint, can you see my PowerPoint?
Yes, sir.
All right. So
Okay.
bear with me. So it's bear with me, please. So it's hold on. So DevOps, it's a collaboration between development and operations. So it's development and operations coming together to work together, to build applications and make things make products better, basically.
Okay.
Yeah.
Then Docker.
Yeah.
Without Docker as part of your tools, can you still perform or work in a DevOps environment?
Yes.
Using other tools. Yeah.
Yes. So without Docker, you can work in a basically you can do test automation without running Docker. Docker is just it's just a container that holds your microservices. So rather than rather than run your microservices through the containers, yeah, you can also run them through your IDE. Yeah. So basically, for a tester, it is not mandatory that you run your microservices on Docker. You can run them through. You can kickstart your microservices from your IDE on its own.
I've always thought microservices means building things in like smaller bits, you know.
No. Microservices. No. So, all right. So, for instance, if you have a database, you're building an application, you have the front end. The front end will have its own microservice. The back end will have its own microservice. Your database will have its own microservices. So, all these things are small chunks of your database working in isolation, but helping you to, power to power up your application. So, they are doing that little bit in isolation to help you build the application. Yeah.
Okay. Thank you very much. Very clear. Thank you.
Yeah. Yep. So we have about 4 minutes more to go. Any more questions? All right. I don't know. Yeah, DG. I don't know if you have anything to say.
Hello, sir.
Hello.
Yeah, when these lessons going to be ready in the group chat? Because the last one that we did last week, I couldn't listen to all the lessons, and I'm still waiting on the proper one to send to the group chat. When is it going to be ready? When is it going to be available in the group chat for us to like rewatch and to get it? Because we have kids and we couldn't focus on that lesson at that same day.
Okay, I think the question is for me, right? So yeah. So I've replied on the Telegram group, right? If you bear with me, right? So we are a small team. We do also work, and the same way you have family, we have family too. So I will, like I said last time also, I'll try to post it before the next meeting. So just bear with me. So as things progresses, so we're going to get more people to be doing that for us. So yeah, if you also want to help, so we need more people to help us in different areas. So that's why we need all the answer we can get. So
okay, sir. Okay, sir. Thank you, sir.
Okay.
Hello, DG. Yeah. I don't know if anyone has any more questions.
All right. So if there's no more question, I think we meet on Thursday for the last part of the manual testing, which is introduction to yeah. So then from next week, from upper week, we start the automation. I don't appreciate, Edward. Maybe you're not listening to what I just said. Okay. All right. Well, so if there's no other question, we will call it a day. Thank you so much. So we see you next week. So yeah, we see. There will be final parts. Yeah, for the training for the manual training on Thursday. So then there will be another one for the practical part next week. So and then we start the automation on Thursday, next Thursday, or possible Thursday. Anyway. Okay, thank you everyone. Bye.